Okay, let's finish the last 3 pages. I want you to do the first 2 pages for the past paper question first, and I'll tell you how do you actually do for the last page. So let's do the first 2 pages by yourself first. Pause the video and we'll check the answers together. Okay, so very simple stuff actually. This is the, well, name the logic gate. So this is AND gate. So once again, capitalize the word AND. And yeah, that's all. For part 2, this is a truth table you need to fill in, and this is apparently a NOR gate because this is OR gate, and this circle show that it is the NOT gate. So what you have to do is just think about OR gate and reverse the result. So 0 or 0 give you 0 and then change it to 1. 1 or 0 give you 1 and change it to 0. Same for the next one. 1 or 1 is 1, change it to 0. Okay, so this is the result for NOR gate. Okay, so next part show you a rather complicated circuit, but it's actually quite simple. You may want to read this, but actually there's nothing very important information here. What you have to do is set it will open when the output f is 1, and actually this is not important as well. So what you have to do is it's like a backward engineering question in maths or IQ question. It tells you that the result is 1, so I'll recommend you to write down the number 1 here and then you work it backward. So let's do it. This is AND gate. You may want to write down here. So the only way that you can get result as 1 is if this is 1 and 1 here for D and E. So actually 1 and 1 you can write here, and let's write here as well. And so let's look at the lower one here. This is a NOT gate. So before that means this is 0, and that is C simply. Yeah, so sorry, C is 0, and same for AB here. This one is also an AND gate. So the only way again you can get 1 is if these two are both 1, and that's it. All right, very simple. Next question, you will find, okay, the name of this logic gate. So this again is the NOT gate, and B is AND gates, and that's the 2 marks. Next part is, okay, this is a bit more complicated. It says the temperature sensor is high, or we use the number 1 to represent, or the light sensor is high, or use the number 1 to represent. So it said when it's dark and cold. So let's do it. Dark for light sensor means 0, temperature sensor cold is 0. So let's write down like this. Strongly recommend you to write down during the exam or when you solve the problem. So let's just simply use your logic to solve the problem. So 0 going through a NOT gate. This is a NOT gate. Become 1. The wire here seems simply transfer the signal 0. So 0 and 1. This is again AND gate. Give you 0. Relay just simply transfer the voltage or amplify the voltage. 0 amplified, no matter how much you amplify, is still 0. So 0. Wait, is this what we need to do? A and B. A. Okay, so A is 1. Yeah, B is 0. Okay, so this is for that 2 gates. So let's start over for the next part. Dark and warm. So temperature change to 1, light remain the same. This is 1, this become 1 through the NOT gate, and 1 and 1 give 1. So 1 and 1. Okay, let's start over for the next one. Bright and warm. So this time it's 1 and 1 for light sensor and temperature sensor. So here is we got 1. After the NOT gate we become 0 here. 1 and 0 give you 0. So that's it. So the answer is 0, 0. Okay. Suggest why B, okay, this logic gate is connected to relay rather than direct to lamp. Okay, so that's basically is asking you the purpose of using a relay. So as I said, you may say the voltage may not be high enough, and therefore we need to amplify the voltage. So the keyword is amplified the voltage so that you can switch on the lamp. all right, you can fill in the rest, all right, amplify so that you can switch on the lamp. So maybe the input system here, the voltage is rather low, but then using the relay, you can then switch on the lamp with a higher voltage like as how it normally operates. Part 2, relay switch on when input is high. Okay, which of the three combination would be switching on the lamp? So it's when B is 0. So apparently we have the second one. As you can see, this is 0, so let me change the color. So it's not gonna work. So this is not gonna work. This is not gonna work. Only when it is dark and warm. Okay, so you can copy here. Suggest a practical use of the circuit. So let's take a look of this. The lamp will switch on when it is dark and warm. And think about this, the lamp would also switch off when it's dark and cold, or bright or warm. So that actually means, or you can think about, it's more like automation system at home. When there's somebody at home but the light is not switched on because it is dark, or maybe at night, all right, it's dark, then you switch on the lamp. How you know there's a person is by using a temperature sensor, knowing that the temperature is warm, then you switch on the light. So this is a practical application. At the same time, when it is dark but there's no people around, so therefore it's cold, then you don't have to switch on the lamp. At the same time, when it is bright outside, so maybe during the daytime, even there's a person here, you don't have to switch on the lamp. So this is all logical. So you can put down the practical use as maybe like an auto lighting system, something like that. Yeah, in-house, maybe, or in-house or indoor auto lighting system, something like that. Or you can write a description saying that when it is dark and there is a person present, then you switch on the light. Okay, you can phrase it yourself. Last page. All right, this is the question I like the most actually. Like if you look at the past paper question, you find those are quite simple and a little bit boring, to be honest. It's just working with like 0 or 1. Here is a question I extract from your textbook, and the reason why I find it the most interesting is here is said you can read the whole paragraph. So this is talking about it's a system where it will allow you to have a security because there's a hidden switch, and in order to switch on the car to let the car run, you need the ignition switch as well. So instead of looking into this question, okay, you don't have to do this question. What I want you to do is I give you the answer key here. This is actually answer key. You can look at the answer key like at the back of your book. This is answer key that they gave you, and I want you to analyze it first, because, or apparently, if you look at the question that I asked you to do, this answer key is nonsense. All right, the answer key is actually wrong. So what I would say is I want you to analyze it first and explain to me why it doesn't work properly, and then you try to see how you can change it. Okay, so actually this system, you just have to tweak one thing to make it work properly. So see whether you can find it out by yourself. It's a very interesting challenge for you to do. So pause the video now and try to work it out. Okay, so to make it easier to follow, I will name the hidden switch as H, ignition switch as I over here. So again, you have 1 or 0 for either one of them, and the alarm as A and motor as M. Okay, so let's try to analyze what happened with the answer key given. Okay, so we have 4 cases as usual, and let's just do one by one. So 0 0, again you should write it on the the diagram to make it easier to work. So after NOT gate become 1, so 1 here, and this wire up to here become 1, and then this 0 which simply transfer to here, and 0 transfer to here. 1 and 0 is 0, 1 and 0 is 0. Okay, so 0, 0 here. Okay, this is the result. And let's just work out the other three. 0, 1. So 1 here and 1 here, 1, 1. Okay, so 1 and 1. We got 1 and 0. Becomes 0, 0, 0. Transfer the 0 here, transfer the 0 here. 0 and 0, 0 and 0. So 0, 0. Okay. Lastly, we have 1 and 1. So not 1 becomes 0. 0 transfer here, 0 transfer here, 1 transfer here, 1 transfer here, and 0, 0. Okay, in that case, 0, 0. Okay, so this is how the truth table works, and it is really helpful for you to just simply work out all the possibilities, because in fact, no matter what happened inside the box, like the logic gates here, doesn't really matter a lot to the user. To the user, it's more about what you have input and what have been output, like this. So let's take a look here. What happened is when the hidden switch is off, ignition is off, the car doesn't move. That's very normal. So this case, I think, is perfectly fine. Next one, hidden switch is off. That means it's a switch where you want to make sure that someone who is not the owner of the car, somehow if they switch on the car, that means that's the case we are having right now. So basically, this is saying someone stole your car who doesn't know there's a hidden switch, and they try to switch on the car and try to steal your car basically. And what happened is the car would actually be moving because the motor is 1, which is apparently not good. At the same time, the alarm is on as well. So what is this actually? This is nonsense. This is basically an ambulance, you may say, moving and beeping, alarming all the time. But anyway, this is not what is intended to do. So this is problematic for sure. Next one, the ignition is not on. Hidden switch doesn't actually matter. The car doesn't, do anything. So this is fine. Lastly, you are trying to switch on the car because hidden switch is on and ignition switch is on. So you want to apparently drive the car. So you are the owner, of course, you can drive the car normally. However, what you see here is the car does not actually move. So again, this is nonsense. You are the one owning the car, but you can't drive the car at all. So again, this whole schematic diagram or circuit would not work properly. So how do we do that? If you still haven't figured out how to work it out, I'll give you more time. Pause the video and continue when you can think about it. Okay, so here is the correct answer for the diagram, and let's check the result again to see whether that is logical or not. So the things that I changed is there was a wire here. After the NOT gate, there's one wire going to this AND gate. I'm going to remove that. Okay, I'm going to delete and remove that. Instead, I would actually add a wire from here and go to AND gate, all right, below. So basically that means you just reverse the input here. So what I would have here is for 0, 0, we have 1 here, and then 0 and 0 here, and here is 0. So we have 0, 0. Okay, so actually it was fine. And let's try the next one. We have 0 and 1, and then 0 got copy here, 1 copy here, 0 become 1 here, and then this 1 got copy here, and 1 give you 1, and the motor would 1 and 0 give you 0. Okay, so this is actually fine because this is a case when somebody want to steal your car and you want the alarm to be on, which is good. At the same time, you don't want the car be able to move apparently. So you can apparently you can then realize that is what happened. Someone stealing your car. Next is 1, 0. So we have 1 reverse to be 0 here, and then 1 copy to this, 0 copy to this, 0 copy to this. 0 and 0 is 0, 1 and 0 is 0. So when no one is switching on the ignition, so no one is actually trying to drive the car at all, nothing happens, so this is good. Lastly is when you drive the car, so 1 and 1. 1 got copy here, 1 copy here, 1 copy here, and 1 reverse becomes 0. So alarm 0, 1 becomes 0, 1 and 1 become 1. Okay, so this is perfectly fine. This is the correct solution because you can see it on the truth table that it actually works at all. When you drive the car, of course you don't want the alarm to be on, and you can drive the car apparently. So this is the correct answer. Okay, isn't this very interesting to us? And I think through this then you can understand how come we have to learn logic gate, because it's very useful when we do programming or when you build an electrical circuit. That's all for the whole chapter.